All right, everybody, let's get started. My name is Stephen Feuerstein. I'm the Oracle Developer Advocate for PL/SQL. I'm the guy who's been working on PL/SQL since 1991, almost nonstop. And I'm here with Chris Saxon, who's a member of my Developer Advocates team. He focuses on SQL and on PL/SQL. And we're here to answer your questions about PL/SQL and also the spillover into SQL. But what I'm going to do first is a short presentation on conditional compilation in PL/SQL. So what is conditional compilation? So the basic idea behind conditional compilation is that we give you a way, or the compiler gives you a way, to tell the compiler what code to include or not include when it's going to compile your code. It's sort of a meta language, a meta set of directions to the compiler. And you do that through compiler directives. So why would you want to use conditional compilation? Probably the number one reason is to write code that will compile and run under different versions of Oracle. So you've got multiple versions of Oracle database. And you may have a situation where you're deploying this app on multiple instances or multiple versions of Oracle, certainly if you're selling a product that needs to support multiple versions of the database. And the common approach to dealing with that is lowest common denominator coding. I'd love to take advantage of that great new feature in 12c, but I can't. I have to support 11 and 10 and who knows what else. So we only use the feature set available on the lowest supported version, which is a pretty bad way to go. Alternatively, you could have multiple files of your programs, and this is the 12c version, this is the 11g version, etc. But even better is to have a one body of code that actually has logic branches in it that says, if I'm running on 12, use this code. If I'm running on 11, use this code. You might also use conditional compilation to run different versions of your code for test, debug, and production phases. So the requirements when you're building your code in terms of instrumentation, in terms of tracing and debugging, might be a bit different than what you want to have in your test phase and your production phase. And you can use conditional compilation flags to vary that code. Another common technique that we use conditional compilation for is to test private subprograms. So if I've got I have a package spec with 3 programs in it, but I have 100 subprograms in the package body that support those 3. Usually those things are not designed for direct testing, but if I did want to directly test one of them, I can't. They're hidden away in the package body, but I can put them in the package spec and test them that way. And with conditional compilation, I can say, while I'm testing, expose them in the spec. While I'm in production, hide them away. And a variation on that is avoid repetition in A/B testing code. I want to test 16 different variations. Do I want to have 16 copies of the code with lots of repetition? Maybe not. Now, assuming that this is of interest to you coming out of this talk, I strongly encourage you to take a look at Bryn Llewellyn's white paper on conditional compilation. Here's a bit.ly to get you there faster and easier. Of course, you can just search on conditional compilation Llewellyn. I expect that will do it. And what you'll find is a really extensive treatment of this topic. Written back in 2005, but that's okay, it still works. And there's lots to cover in conditional compilation. And I'm not going to cover all of this, obviously, today, except to give you a flavor, a taste of what you can do with this great technology. But there's a lot to look at. So I encourage you, if you're about to explore using conditional compilation in your production code, because it does end up usually going to production, you want to make sure you dot every I and cross every T. Read this white paper. Okay. Cruising along. So there are 3 different types of compiler directives to use in conditional compilation. The key thing to remember is that they all pretty much involve $signs. If you see $signs in your PL/SQL code or somebody else's, that means conditional compilation is at work. So we essentially have inquiry directives, which are kind of like flags or variables. They return a value that can be used in the select directive, the $if. We've got the selection directives, essentially conditional logic. If this is true, then do that, else if, else, and end. We don't have an end if, just $end. And so that's the core directive that you use to control which code should be passed on to the compiler or not for actual compilation. And inside these conditions, the $if and $else if, you can reference these flags, the inquiry directives, or static constants in packages. And finally, and in many ways, most interestingly, the error directive. You can use the $error directive to force a compilation error. And I'll show you an example of using that to improve or to apply a QA check in your code. So what I'm going to do is quickly run through a number of examples of this code, of using conditional compilation, so you can get a sense of what's involved. And then I'll show you some scripts on LiveSQL, and then we'll open it up for questions. So here's an example of both setting PL/SQL conditional compilation flags and then using them. So in my alter session statement, and I could say alter procedure X set PL/SQL flags, CC flags, or alter package, etc., or just set it for the whole session. And then I provide the name of my flag and the value, and they can be Booleans or integers. You can't have varchar2 values. There are a lot of rules around how you can construct your conditional compilation expressions. And here inside my procedure, calculate totals, I'm saying if I've got debug turned on and my trace level is at least 5, then put this dbms output.put line call into my compiled code, and therefore I will see the output when I run it. Otherwise, there's no else. So if this is not true, then this output is not put into my code, and I simply have my application logic. So this is a very basic example of how you can use these conditional compilation flags, which you can simply define on the fly in your alter session statements or alter object statements, and then use them to control what gets compiled. There are lots of different ways you can apply that idea. Now, you might say to yourself, well, that's interesting, but how do I know it's actually running in my database? So you've got all this complicated meta-conditional logic. What's running? So there's a package called a dbms preprocessor that you can run to extract the actual text that's been compiled into the database. So the all source view will have this version of code with all your $signs in it. But the post-process source code will show something like this. So as you can see, since I don't have the optimized level set to 1, all of this is blank. And then we see the part that was included. And what you'll see, and I'll show you this again in LiveSQL, is that Oracle's very careful about maintaining the white space in your code, so that if this is line number 15 here, this is line number 15 here. It doesn't compress the code. Your stack traces and your back traces and so on will go all the way back to your line of code in all source. Now, when you want to write code that's dependent on the database version, we have a special new package called dbms db version. It's available in all versions of the database that support conditional compilation, which started in 10G. And they consist of a bunch of Boolean constants showing you the absolute and relative version information. Let's take a look. So here's the documentation for dbms db version. And this is the sort of content that you'll find in the package. This is up through 12.2. So if you ever want to be able to just do a quick check on what your version and release is, you can use this package. So version is 12, release is 2. And then we have a set of ever-growing constants that allow us to do relative analysis in our code. If I'm running on a version less than or equal to 11.1, I want to do this. If I'm running on a version that's 12.1 and less, do this. Otherwise, else takes you down through the next step. So every version of the database has one of these packages in it with the appropriate set of constants. So here's a very simple example of using this package. If the database version is less than or equal to 10.1, then I'm going to use this body of code. Else, I'm going to use this body of code. Specifically, in 10G Release 2, we added the indices of and values of clauses for the for all statement, which allows us to work with sparse collections much more easily. Prior to 10.2, I would have had to have taken my array that had gaps in it and densify it, making sure there are no gaps between the first and last. Don't have to do that anymore, but here's an example of how I can have this branch in my code that allows this single body of code to run on 10.1 or less and utilize the appropriate feature set there, but on 10.2 and above, take advantage of the newer features in the database. And an error directive example. So suppose that I've got a piece of code that is very compute intensive, and I want to make sure that whenever this code is compiled, the optimization level is set to at least 2. Here's the way you can do it inside the code itself. If plsql optimized level, and this is a predefined conditional compilation flag, it tells you the optimization level currently at work for this procedure. If it's less than 2, then I'm going to cause a compilation error to be raised, and I provide the message, program must be compiled with full optimization. So that's one example of how you can use $error to build QA checks into your code itself. Now, before I get to the get to knows, I believe we had a question in the chat. Let's see.
So there is a question come in, but it's in, I guess, Spanish or Portuguese or something. So unfortunately, I can't read it. But
well, use Google Translate while I'm talking to these guys. Come on, Chris.
Okay.
Como luce ese código sin las banderas. I can talk Spanish, okay? I'm not that good at understanding it. So Chris will sort that out. I've got another question here. What is the usefulness of having a conditional compilation test for? Am I running in a database release before the introduction of conditional compilation? Ha! I believe that what Tim is referring to, if we go back and look at the packages, look at that, 9. And I said it was introduced in 10. Actually, I misspoke a little bit. So conditional compilation was actually first introduced in Oracle 11G, but this decision was made to make it available also in certain patch releases of 9, 9i, and 10G. So part of the reason is that when they first released 11G, the main motivator was this DBMS-DB version forking. And if it didn't support any of the previous releases, well, it wasn't much use. So that's why you see Oracle 9 and 10 showing up there, even though the actual first release date or first release version of the full feature was 11G. So
okay, so we've got we've got a translation now. So we know that what does the code look like without the flags?
Right. So the question is, what does the code look like without all those flags? And that goes back to this idea of viewing the print post-process source. That's quite a tongue twister. Now, let me just zoom back over to where I was, because what I'm going to do is take you over to LiveSQL. So I've talked about a number of these features. As you may know from previous office hour sessions and my webcasts in general, these days, what I like to do is show you stuff in LiveSQL because it's such a great demonstration environment. So if you go to livesql.oracle.com, sign in, and then search on conditional compilation, you'll find a number of scripts I've created, and I think there's one here from the doc team as well, on using conditional compilation. Now here's a view post-process code. Let's take a look. So here's that example of using my error directive, or it doesn't have the error directive, but it says if my optimization level is 1, then use this code. Otherwise, use this code. So you should see a different comment in your text, which won't show up in in runtime, depending on the optimization level. So I compile this code. The default level is 2. So when I say print process post-process source, I see this output, and you can see it's got the fast version. If I set my optimization level to 1, right, so I'm just for this single procedure, I'm going to recompile, and I'm going to specify that the optimization level should be set to 1. I don't actually recreate or replace my code from this source. Then when I look at my code again, so I'm going to look at this post-process procedure. Notice I've got the line numbers in here now. It's a little bit fancier, but in any case, the main thing is you see I've now gone into the fork for the slow version because of my optimization level. So this is the basic idea. There's nothing built into the data dictionary views that lets you see the source code post-compilation processing. All source will show you this. You've got to run the preprocessor subprogram to then show you the output or show you the version of your code. And I don't think there's anything in SQL Developer that does this for you automatically either. So you probably want to build a report that would take the appropriate parameters and then spit out the content. Or you can go to this LiveSQL script and grab this code and use it yourself. Okay. What I'm going to do is go back and pull up that set of scripts again. There we go. So here's require a minimum optimization level for unit. So I set my level to 1 for my session. I compile my program with this flag in it, with this conditional compilation check. And notice it fails with an error. PLS 179, $ error. And there's the message that I provided. So that's how you can use the $ error directive. And here's another example I mentioned at the beginning, A/B testing. This is an idea that Bryn Llewellyn, the product manager for PL SQL, promotes very heavily. He and I both do a lot of building of scripts to test different variations of code, and there might be 5 or 10 different variations. And what you can all too often end up doing is taking copy and paste of your code blocks and then making minor changes in each one of the blocks. It's very hard to look at a block of code and see what's changed, and it's very hard for anybody else to take that code and work with it. An alternative approach is using conditional compilation. So in this case, what I'm going to do is test the different behaviors between a nested table and an index by or associative array collection. So if I say use index by, if it's set to true, then it adds the index by clause. Otherwise, it doesn't. And when I run this code, so if I say true, when I run my test, I see that I've got 0 elements in my array. But when I say don't use the index by, run my test again, now I get an error, reference to uninitialized collection, driving home the point that with nested tables, without the index by clause, you've got to initialize your collection by calling the constructor function. So, but the main point here is that I have one block of code with the variations for my testing inside it based on my conditional compilation flags. Let's see. Here's an example of exposing otherwise hidden private subprograms into your package spec for testing. So suppose I have a package called Sense of Humor. I calculate how funny a joke is using, of course, machine learning and artificial intelligence. And I've got these other functions, humor level and maturity level. And these are inside the package body. And they're used by the calculate how funny procedure. So generally speaking, I can't directly test these subprograms. But with conditional compilation, I can say if I want to show my private joke programs, for example, right here, then when I recompile my package, those programs will now be in the package spec, and I can test them directly. Now that, by the way, brings me to my good to knows. So the first and most important good to know for conditional compilation is you've got to set the production behavior to reflect as if no conditional compilation flags were set. So you don't want to take any chances in production of things not working the way they should. So for example, in this piece of code, when this goes production, I really don't want these things to be showing up. Is it going to cause a problem in production code? Maybe not, but in any case, it's not for general consumption use. Now, the way conditional compilation flags work is that if this value has not been set, it evaluates to null. If null is never true, same logic as we have in regular conditional logic in PL/SQL. So unless this statement is executed, and it says true for show private joke programs, this code will be production ready. And that's the general rule that you want to follow. Whatever logic you have in your conditional statements, always make sure that, assuming nothing has been set in those deployment scripts, no conditional compilation flags have been set, it works as it should in production. Second good to know. Watch out for the 302 error, component version LE 9.1 or version LE 12.2 must be declared by referencing version constants in ascending order or by nesting the references there.
Yeah, I had a situation where we had some code that required an extra parameter to one of the system procedures, the UTL HTTP, as we have shown there. And what this meant was that we required that extra parameter only in the 12.2 database. But compiling it prior to that with that extra parameter on the end, it would fail compilation because that parameter is not there in the package. If I didn't add the first if dbmsdb version line, then my Oracle 11 database complains that it doesn't know about versions 12 onwards, and so it wouldn't recognize the LE 12.1 test. So
excellent. Yeah,
go ahead. To nest them.
So this is a particular instance in which the only consideration was not, okay, on 9 I'm going to do it this way, on 10 I'm going to do it that way. It's on 12.2 I've got a new feature I want to start using. So it would be very easy to be inclined to say, okay, fine. Well, if I'm on 12.1, if I am, let's see, version 12.1, less than or equal to 12.1, then nothing else, add this parameter. The problem is that when this code runs on 11, or 9 or 10 or whatever. This constant is not defined in the package. These constants, like 12.1 and 12.2, are added only as the new version is in place. I suppose we could actually create a version of this package in 19 coming up that has 20 and 21 and 22 just all set to false, but that's not the way we do it. So in this situation, you can't just reference that high-level version constant. And the approach to take instead, as Tim was just saying, my SQL developer is, I believe, automatically reconnecting. So what you would do instead is nest the invocations so that first you check to see if you're on less than or equal to 11. And if you're not, then you go into the clause that references the 12 constants and you will not fail. So be careful of the order of referencing those variables.
So something's just come in. So can you explain a bit more about the A/B testing with conditional compilation? Can you use this in production? You probably need to recompile the objects if you want to switch from A to B.
That's absolutely the case. Okay, so let's go over to LiveSQL and let's see. Will A/B find it? Yay. Right. So with conditional compilation in general, it is compilation. So the change that you make to your conditional compilation flags or other settings in your environment, like the optimization level setting, only take effect when you actually do recompile the code. So let's see. Can you use this in production? You certainly can use it in production, but it will require that additional compilation. I don't think this really is something that would make sense for what we usually mean by production, applications that are running under user control. It's more a matter of I've got several different variations that I want to test. For example, the example that Bryn often uses on this is the UDF pragma. So pragma UDF, introduced in 12C, 12.1, tells the compiler that this function is going to be used as a user-defined function in SQL. So get it ready. And it does some extra steps at compilation time. It would usually wait until runtime in order to reduce the cost of the context switch as it's moving between the SQL and PL/SQL engines. Turns out that UDF feature only works for certain data types, and there are a number of other variations. And Bryn wanted to build out a pretty exhaustive demonstration of where UDF helps and where it doesn't. So he might have 25 different versions of the test that he wants to run for varchar2, for number, for date, for integer. Instead of 25 copies of that code, he just changes the conditional compilation flag and sets a different data type. So hopefully that gives you more clarification. GK Ross. And another question from Tony, will conditional compilation work inside a view? Huh. I don't believe so. Chris, have you ever?
I don't know off the top of my head. Views are more SQL objects rather than PL/SQL. So I'd have to check that to be absolutely certain.
Well, let's just check it now. I'm pretty sure it's not the case.
So
go ahead.
Well, Stephen's checking that. We've had something came in a bit above saying when it's recommended to use the feature, for example, to work with a different database version and use the feature that's not released. So that is absolutely a valid use case for this. So if you need to support multiple versions of Oracle database, so you're deploying your application to customers on site, and some of them are on 12 and some are on 11 and whatever, so you need to have different versions of your code because of that, then conditional compilation is exactly a way to help manage that. And there's a follow-up, or when I want to use a different path to do work. I think you'll have to give us an example of what you mean by that, but I don't know if you've got anything else to add or say, Stephen.
No, I don't. In fact, I'm not even seeing those chat comments. Interesting.
Okay.
But as you can see, I did a create or replace view. I don't think I did anything wrong in the syntax, and it's not working. Let's just verify that. But we're just doing this to make sure it's pretty clear. $if, $endif is select
star. As, not instead of is.
Darn, I can again. Yeah,
as versus is.
That doesn't make any sense at all. PL/SQL. Anyway, sorry, folks. Let's see. Actually, I can look at my session. That's it.
Yeah. Oh, the handy. You've got your full history there.
Full history. Select from dual, create as. Invalid character. Okay. So no, conditional compilation is a PL/SQL feature. Create or replace view is a SQL database object. Okay. Other questions?
So I think it's worth mentioning, and another use case for conditional compilation is disabling instrumentation in production. So, or certain types of debugging. Personally, I think you should always have your debugging available in all environments, but in some cases, you absolutely need the performance. You can't avoid, and you want to avoid any absolute overheads. In which case, you can have your logging, debugging code in dev and test, and then just have it completely disabled in production. So personally, I would urge you to rethink slightly, but it is something that some people feel the need to do.
Yeah, I just to reinforce what Chris said, tracing it, the most important place to have instrumentation is in production when a production problem is being experienced. So this is probably not a great example of where you'd want to conditionally turn things on and off in your code, but it certainly drives the point home. And we have a comment or a question from Tim. If I use the $debug mode test, doesn't all PL/SQL compile with debug in 12.2 plus? Sorry, Tim, what is the debug mode test? What do you mean by that?
Yeah, I'm not sure either.
I thought there was a standard flag set for if this is compiled in debug mode, but if there's not a standard such flag, then it's an irrelevant question.
Yeah, I don't recall. And also, just so you know, the debug mode has been deprecated officially by Oracle, and it's basically just optimization level 1. So certainly that would be equivalent to setting your optimization level to 1, and I don't recall about a specific debug mode. Well, there's the PL/SQL, yeah. So there is a predefined $$ flag for whether or not debug mode is turned on for a procedure for a program unit. So that's always available to you. You can ask, is debug turned on in this module? But you can't turn on debug mode through a conditional compilation flag. That's my understanding. Anything else? All right. Well, in that case.
So we've got, someone's asking some questions to me privately. Hopefully they'll share them publicly in a second, but they're saying, select from dual, fetch first row only. Yes, okay. So they've got they're using some 12c syntax in their query, which doesn't work on 11g, unsurprisingly. So they're asking if that's a valid use of conditional compilation. And yes, the short answer is yes. That would,
as long as the code is inside PL/SQL and not, for example, in a view where you're trying to modify if you're trying to put conditional flagging around part of a SQL statement that's in a view or anywhere outside of PL/SQL, it won't work, which is another good reason to always have your SQL statements inside your PL/SQL program units. Another great advantage of PL/SQL for SQL development. All right. Anything else? All right. Well, thanks for joining us. Our hour is almost up, and I'm sure you've all got lots of things to do. Thanks for joining us today, and hopefully you found conditional compilation an interesting feature to explore. So check out Bryn Llewellyn's white paper. Make sure you understand it fully. Go to LiveSQL, play around with the different features, and let us know if you have any further questions. You can always go to asktom.oracle.com and ask Chris and ask Connor and Maria and the others, and they'll get right to it. Thanks so much for joining us, and happy PL/SQL and SQL and Oracle database coding. Thanks, Chris.
thank you. Bye-bye. Thanks, Stephen. Thank you, everyone.